Lesson 97, Recursive Rules for Sequences. First off, let's review what a sequence is. Sequence is just an ordered list of numbers that follow a pattern or rule. And when we have these sequences, there's going to be a formula. And in the formula, you're going to see a subscript n, which just means the term value and the term position. So a is the value, n is the position. So anytime you see a subscript, that's going to tell you the position, which term are you trying to find. So the recursive formula is going to be a subscript 1, which just means the first term, and a subscript n minus 1. So whatever term you're finding, you plug that in for n minus 1. So it's going to be referring to the previous term. So we'll look at more of that as we go out throughout the lesson. Let's look at our first question. Write a recursive formula for the following sequence. So here I need to determine how do I go from 2 to 4 to 8 to 16 and so on. I could add 2 each time, but 4 plus 2 doesn't give me 8, so it can't be plus 2. If I multiply by 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, so I know that I'm multiplying by 2 each time. So to write the recursive formula for this one, first term is 2, and then the remaining part, we would have everything is multiplied by 2, and it'd be a subscript n minus 1. So whatever term we're trying to find, we put in for n, and then we multiply our number by 2. If I were trying to find the third term, I would put a 3 in here. So 3 minus 1 is 2, so the second term is 4. 2 times 4 would give us 8, and this would be our third term. And if you look up here, our third term is 8. Next, which formula below generates the terms of the following sequence? 2, 3, 5, 9, 17, 33. So we know it cannot be B. Because it doesn't tell us what the first term is, so it's not B. Let's look at A. If I put, for first term is 2, which it is, and now I have my formula to a subscript n minus 1 minus 1. If I were to take my second term, so say if we're trying to find the second term, I put a 2 in for n. 2 minus 1 is 1. So 2 times 2 is 4. 4 minus 1 is 3, which is what we have here. If we were trying to find the third term, so I'd put a 3 in for n. 3 minus 1 is 2. So the second term is 3. 2 times 3 is 6. 6 minus 1 is 5. So that would work here. C would not work because if you were trying to find the second term, you put a 2 in for n. 2 minus 1 is 1. So our first term is 2. 2 plus 1 is 3. That does work. But if I were to find the second term, or the third term, I would put a 3 in. 3 minus 1 is 2. So our second term is 3. 3 plus 1 is 4, not 5. So C does not work. Next one, write a recursive formula for the following sequence. 1, 4, 16, 64. Here I'm multiplying by 4 each time. So our recursive formula, first term is being 1, and then the second part of our formula be, since we're multiplying everything by 4, it'd be 4 times a subscript n minus 1. Next problem, this formula shows how to find any term of a sequence. Use the formula to find the first 4 terms of the sequence. then rewrites the recursive formula. So we're going to be using this formula right here. So to find the first term, I put a 1 in for n. This will give us 2 times 1 is 2, plus 1 is 3. Second term, put a 2 in for n. That would give us 5. Third term, put a 3 in for n. 2 times 3 is 6, plus 1 is 7. And to find the fourth term, put a 4 in for n. 2 times 4 is 8. 8 plus 1 is 9. So now if we rewrite the formula, our first term is 3, and our recursive formula would be a subscript n minus 1. But if you look at it, we're going 3, 5, 7, 9. We're adding 2 each time, so it's going to be a plus 2. So the previous term plus 2. A recursive formula for sequence is a subscript 1 equals 5. So the first term is 5. And the formula we're going to be using is 3 times the previous term. So to find the second term, I put a 2 in for n. So this would be 3 times a subscript 2 minus 1, which will give us 1, which is our first term. So this would be 5. 3 times 5 will give us our second term, which will give us an answer of 15. Find the third term, a subscript 3 equals 3 times a subscript 3 minus 1. 3 minus 1 is 2. So our second term would be 15. Multiply that by 3. That will give us our third term. 3 times 15 would give us 45. Our last couple of questions. The terms of the following sequence are generated with the formula a subscript n times or equals 5n minus 2. Write a recursive formula for this sequence. First off, if you look, we're just adding 5 each time. So a subscript 1 would give us 3. And so the recursive formula, we take a subscript n minus 1, and we are adding 5 each time. And the last one, what are the terms in the following sequence of 729? Write a recursive formula for the sequence and find the term that follows 729. So here, we're just multiplying by 3 each time. So our recursive formula for this one, a subscript 1, or our first term, is 3. And the main part of our formula, so we're multiplying by 3, this would be 3 times a n minus 1. And so if we're trying to find 729, so if our term, the previous term is 729, I'm going to plug that in. So we're trying to find the nth term. So we're going to multiply 3 by the previous one, which is 729, because we're trying to find the one right after 729. So if I take 3 times that, this term would give us 2,187. That is our lesson today on recursive rules for sequences.